Good morning, everybody. Welcome back to lecture number 45. Today it was supposed to be the last lecture, but we will have an additional lecture on Sunday, which is lecture 46. I think that's a substitute for the founding day, right? Which all of you almost missed when we did it online. So now you pay the price. You have to be in class. And if you are absent, it's up to you, but you might miss another surprise, important surprise. It could be a mandatory quiz, who knows? Or it could be a mandatory exercise. Okay? So I'm warning you, there will be something that's mandatory. Okay? So it's better not to be absent, okay? Don't forget, in the Morgan's law, if you see a big bar across the whole thing, what will happen? The big bar you add at the end will cancel only the big bar. Half bar, will it cancel it? We don't care. 75% of the terms have bar, but the last one doesn't have bar. The big bar will cancel it. So don't make a mess. Remember the 3 steps? The 3 steps are: replace every variable with its inverse. The second step, and becomes or becomes, and the last step is what? The big bar. Okay? Today we will talk about another gates that are also used, but they require more complicated logic, okay? So what if I tell you that there is a gate that checks similarity, okay? For example, let's pretend you have a code of 101. Get it? You want to send this code, let's not use the green. You want to send this code across, let's say, Wi-Fi, okay? You will receive it at some end, right? So what will happen is, you hope that the code is 101. But is this a true case? Well, we don't know. Sometimes the signal gets delayed, right? Sometimes the signal gets lost. Sometimes the signal, maybe one bit becomes 0 for whatever reason. So let's assume that this bit became 0. What is the signal now? 100. Okay? How can you verify that this signal matches the original signal?
We compare bit by bit.
You compare bit by bit. So another application is, instead of sending it one time, why not we send it 2 times, right? On another frequency or on another channel. Let's say someone sends you and tells you to send an important message to Fawaz. You don't have to attend one. Let's say you want to send an important message to KFUPM registrar. You're graduating. You have to send 2 messages. So let's say you send one in Wi-Fi. What's the other Wi-Fi? One is what? 5G. The other is what?
4G.
Let's say 4G. Another technology. Is there a Wi-Fi 5G? No, 6G, right?
5 or 5G?
It's now no, not G. 6.
No.
Wi-Fi 6.
Not commercial.
The latest one is 6. Let's say it's 6. Okay. The previous version is, let's say old. Let's say new. There is a new Wi-Fi, there is an old Wi-Fi. Now if you have a router, you have 5G, you have regular, right?
2.4.
No, but this is not the Wi-Fi, this is the cellular. Okay? Let's pretend there is a new technology, there is an old technology, and let's say that the signal here in the old technology was 101, and the new technology was 100. So let's compare the bits. 1 and 1.
Match.
They match, right?
0.
No, they match.
They match.
It's not XOR. Okay, you want to use this logic? Okay, let's say 1 and 1 match, so now 0 error. 0, 0 match, 0 error. 0 and 1 match, 1 error. Another way to do it, so here 0 if match. What I can also say 1 if match, right? So this would be what? 1, 1, 0. If I sum all the ones here, what will happen? I have 1. If I sum all the ones here, I have 2. 1, 0. So depending on each logic, you can sum and calculate and check if your result is larger than 0, you will have error in this technology. What is the gate that will compare the bits? It is called the XOR gates. If the results are the same, get 0, which is Adnan's gate. If the results are different, the result will be إيش؟ برصار. It will be what? This will be in the final exam. 1 compared with 0, you put 1. There is an error. 0 and 1, there is an error. 1. 1 and 1, are they the same?
Yes.
So 0, no error. So we can reliably say that this logic can be implemented using what? XOR. This logic is what we call it
XNOR.
XNOR. Is it required in this course, XNOR? Not required. XOR is required. Okay? XOR is required. So if you implement XOR, you got how many errors? 1 error. Okay? And the logic of it is called what? A, B prime, ORed with A prime, B. You can create a truth table. You know how to create the truth table? You put A, B, you put intermediate variables, and then here you put A, B prime plus A, B. A prime. So you put 0, 1, 0, 1. You remember this? Rahman, you remember this?
Yes.
And then you put 0, 0, 1, 1. Right? So what is A, B prime? You have to find B primes, which is 0 and 1, 0, 0 and 0, 0, 1 and 1, 1, 1 and 1, 0. And what is A prime B? Keep the B, get A prime. 1 and 0, 0, 1 and 1, 1, 1, 0 and 1, 0 and 0, 0, 0 and 1. I used A prime and then ended with B. Finally, if I find 1 in those two columns, which is the OR, I keep it as 1. 0, 1, 1, 0. So what do you note is the results is 0 if A and B are 0 or 1, they match each other. The result is 1 if they are different. Get it? Get it, ya Hatim? So XOR, what it does, remember the signal 101 and 100 that became 100 and 101. If you get 001, you have 1 error. So if they do not match, report a 1. If they match, report 0. This circuit, the XOR gate, is very, very important. And its symbol is what? Is OR with 2 brackets. This is its symbol. Okay? 2 brackets and OR. So you put 1 bracket, another bracket. And its operation is called A. This means ايش؟ XOR. اللي هو زائد عليه دائرة. Get it? Are we recording? Yes. So is XOR clear?
Yes.
صادق. Is it clear? سلمان ما جاء سلمان. Jihad, is it clear? So quick question, what is the result of this exercise? Starts from left to right. 1 XOR with 0 is what? 1. They are different. 1 XOR with 0. So can you do it across different layers? Yes. What if I replace this with 1? What will happen? 1 XOR with 0. 1 XOR with 1. You see how it's very useful? Okay. So we are done with the most difficult gate, XOR. So we call it the parity check gate, okay? It checks the bits. It is very used in computer, it is very important. And it has so many applications, and the easiest application is transmitting signals, okay? Believe me, in real life, if you send signals, you'll always have issues. That's why when we send, there is a software to analyze whatever sent. It's called Wireshark, okay? It's free. You can download it, and you can see what's going on in your network, okay? It's a good thing to know. Interview question, Khalid. If you apply for a job for STC, and you're a mechanical or aerospace engineer, and you tell them, oh, I have had a small experience, a one-day experience with Wireshark, you will get the job. Okay? Afterwards, Ramadan. Remember, there might be a big surprise on Sunday, okay? So let's look at this slide again. So the XOR, it's called exclusive OR operation for two logic variables, is defined. Two similar inputs, the output is 0. Two different inputs, the output is 1, and this is the operation. I already told you before about NAND and OR. So if you have and there is a bubble, or there is OR, and there is a bubble, you have to invert the output. So what will happen is, this will be AB all bar, this will be A plus B or all bar. And the logic is, if one of those is 1, the output will always be 0. If one of them is 1, the output will be always 0. If one of them is 0, the output is 1. عكس الNAND والNOR. So the AND will become more likely to generate 1, and the OR will become more likely to generate zeros. And then we have also a buffer. Remember the buffer I told you about the op-amp? A buffer is whatever in goes out, and it is just the triangle without what? Without the bubble. There is also the gate XNOR, which is XOR with a bubble, which was doing the second application. Inshallah, Maiji, but if it comes in the final, now you know. Well, I didn't know it's in this slide, but it is in this slide, so it's required, okay?
The buffer with aspect?
If XNOR,
The buffer.
yeah, the buffer, if you put 0, you'll get 0. If you put 1, you'll get 1. Similar to the unity gain op-amp. نفس الفكرة.
وش الفائدة منها انتم؟
To isolate the input signal from the output.
So they become the same.
Yeah, that's the benefit of the buffer, is if your signal is, for example, in digital, you have a 5 volt, and over some reason it became 4.3 volts. If you put a buffer, remember the buffer is powered by the circuit, by the chip, زي op-amp. You will get back the 5 volts. That's a clear application to boost the strength of your signal.
So, ايش السمبل حق الجبريك XNOR؟
It doesn't have a symbol.
مو داير عليه
ما أدري حقيقة ما أعرف. But usually you do the XOR and then you put a NOT at the top. That's the easiest way. So you put whatever XOR and then put a big bar. Let's do. Wallah, I never thought about XNOR symbol. Not really. Oh yeah. That's a symbol. They're using it, you're right. It's rarely used, XNOR. But you're right, that's the symbol and that's the logic. So it is required. Adnan made it required for you. No, I'll check. If Dr. Atiyah wrote a question that I didn't teach in the class, the least thing I put either announcement, or maybe I put a video on YouTube, or I put slides, and I'll give you some more info. It's possible. How many days left? 3 weeks? 2 weeks for the final? Okay. Logical sufficiency of NAND gates or NOR gates. Let's take an example. If I put here A and A, what will be the output? Well, if it's 0 and 0, the output will be 0. If it's 1, 1, the output will be 1. So it's A. If I take the NAND and I put same, I can do this, A. If I put A, what will become before the buffer, before the bubble? A. So what is after that?
A bar.
A prime. So is this the inverter? The same. So I can build from a NAND an inverter. So how inverter is built? Using NAND. And tie the two inputs together. This is what we do here. If the input to a NAND are tied together, it's an inverter. De Morgan's though, the OR operation can be realized by inverting the input variables and combining the results in a NAND gate. So, let's pretend, again, we don't have lots of ICs. I want to have OR. This is A or B, right? If you apply De Morgan's law, what will happen? Apply DM, De Morgan. What will happen? The A will become A prime, the B will become B prime,
The O will become prime.
the OR will become AND, and the big bar. صح? What is this? This is A prime ANDed with B prime and inverted. So this is basically A prime, B prime, and inverted. Not only that, I can get the A prime using an inverter. So I can put A and B and get here A prime, B prime. But I told you before, the inverter can be an AND tied with two inputs. So it will become what? Another NAND with the A, another NAND with, tied with the B. And this is equal to OR gate. Yes, I used 3 gates, but for some reason, in semiconductor industry, the cheapest IC to produce is NAND, due to internal transistor configuration. الترانزستورات داخل الناند قليلة وسهلة وما تستخدم طاقة عالية، فلذلك it is used. If you want to have logic gates, it's everything in NAND in real life, and then you do these tricks. You can create an OR using this, you can create an inverter using a NAND. هذا يسمونه الاكتفاء الذاتي، الاكتفاء المنطقي، انك تكتفي بالناند to build any circuit you want. So to build an OR, how many NANDs we need? 3. To build an inverter, how many NANDs do you need? 1. So in other words, do you remember in the IC we had, in the lab we had ANDs like that. Some ICs are NAND. So instead of using 3 ICs, you can use one big IC of NAND and create everything you want. اللي فيها 4.
تكون 1 gate.
No, this is 4 gates
4 gate
with
NAND.
1 chip.
1 OR gate.
Hmm?
يسمونه 1 AC.
Okay?
لو أخذنا الدائرة وديناها ساقين وعكسنا
لا you put here الدائرة.
هيلغي الدائرتين هذي ونعكس إشارة الجيت هيطلع لنا نور جيت.
NOR?
أور.
Or?
إيه.
I don't know.
لو بجيب
Well, if you put bubbles here,
هذيك تروح.
so this will be A,
هيكنسل بعض.
this will be A, this will be B. Yeah, this will be A ANDed with B.
هذا يروح الدائرة هذه تروح.
Yeah, if you remove this and put
يصير
2
OR
more,
gate.
it will be AND.
الآن يصير أور جيت. أور.
أنت إيش تقول؟ تقول أخذت هذا ولا replace the whole?
أعطاني هذه وبجيب الجبريكس equation.
Again, this is too many steps. Yeah, أنت you are removing an AND and replacing the AND with OR.
أغير الدائرة بالجهة الثانية وأعكس إشارة الآن بس.
ودي تخليها OR؟
خليها
خلاص what's the point? You are going back to the original problem.
بدل ما يعني استعمل الجبريكس وأطلع الإكويشن.
الفكرة you want to
Use that.
build if you only have one, you have the option to use NAND only. That's the key, because NAND is, what did I tell you about NAND? Cheapest. Remember, NAND is the cheapest and most efficient. يعني if you want to build a big project, you use what? Now you're telling me you replace it with an OR, with a OR, right? So an OR circuit is also expensive, so we're going back to square one. That's the difference. Inshallah we will not have difficult questions. Finally, NAND, the last thing is NAND. If you put an inverter after, you can get an AND. So now I can create AND or an inverter using only NAND. So NAND followed by an inverter results in an AND. So in summary, to build an inverter using NAND, what to do? Tie the 2 inputs together and use NAND, you will get the A prime. If you want to use OR, if you want to implement OR using NAND, you need 3 NANDs. 2 act as inverters, and the last step is the NAND, and you will get the OR. If you want to build an AND, it's very simple. Have A and B. You tie the input. Here you will have AB. So how many gates you need for AND? 2. Clear? Okay, let's do the check. Jihad, is it clear? No, it's not clear. Hatem? Urassar? Not clear? Siri? Hamad? Sadiq? Faisal? Mishal? Not clear. So Mishal and Jihad, not clear. Sarada clear? Khaldi, not clear. 3, clear? 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 Okay. عندك, what are the basic circuits? Inverter وAND وOR. أنا قاعد أقول لك ما تقدر تبنيهم ما تقدر تبنيهم إلا بناند. ليش؟ عشان نوفر فلوس وعشانها less energy consumption. The first option is how to implement an inverter. You tie the 2 inputs my bad, this is A. If you put A ANDed with A and inverted, what will be?
A point.
A ANDed with A, A. What will be the output?
A point.
A prime. Can I tie this cable here and delete this?
This.
So A ANDed with A, A. Jihad, A ANDed with A, inverted, A prime. So what is this? This is equal to H, inverted. You put A, you get A prime. Get it? Now, if I want to implement OR, which is A plus B, which is one gate, using only NAND, I need 3 gates. 2 for the inverter, you get A and A prime, you get B and B prime. This is inverter, this is ايش؟ inverter, صح؟ خلاص الشكل هذا انت حفظت انه inverter. You put A prime, B prime, and then AND, it will be A prime, B prime, AND. And then there is a bubble, بيصير NOT. So A prime, B prime, NOT, apply De Morgan, you will get the OR. And I did show you using the truth table. Okay? I can show you using the truth table. So to implement the OR using NAND, how many gates يا مشعل؟ هنا. This is, what is this? The whole thing. A, B, you get A plus B. To implement the OR, how many gates? How many NAND gates? 3. 1 2 3. 2 منها تستخدمها كانفرتر، والستيج الثانية اللي هي A prime ANDed with B prime all prime. لو تسوي دي مورغان على هذا بيطلع لك هي A ORed with B. واضح؟ The last circuit NAND followed by inverter. يعني أنت عندك NAND حطيت A AND with B NAND حيطلع A B prime. حط inverter بعدها يشيل prime فيطلع A AND with B. So to implement the AND gate يا جهاد, how many gates you need? 2. 1 3 2. In summary, if you want to implement NOT or AND, how many NANDs? If you want to implement, all of them are 1 original. If you want to implement it using NAND, an inverter, how many you need? 1. An OR, how many you need?
3.
3. The AND, how many you need?
2.
2. حفظ. Okay? Is it clear? So since the basic logic functions AND, OR, or NOT can be realized by using the NAND gates, we conclude that NAND gates are sufficient to realize any logic circuit. واضح؟ واضح يا خالد now? It's clear now? Jihad, is it clear? Mash'al, is it not clear?
No.
If it's not clear, we have a class at 11 a.m. Okay? Let's do this exercise. Well, it's the same thing, right?
No.
Hmm?
No.
Sorry, I have to go to the restroom.
مش هتكرر.
معذرة. So what is this circuit يا جهاد? Inverter. What is this circuit? You have to do it. Is this NAND or OR?
No.
No, this is NOR. So do it. A ORed with A. A. Bubble. A prime. So also you can build an inverter using NOR. How about that? A ORed with B. AB. A plus B. Prime. It will be A prime and B prime. Inverted, it will be OR, another OR. So this is NOR and then NOT. This is what? NOR. بعدين NOT. تصير OR, original. How many gates we need? 2, using NOR. How about this one? And how many gates we need? 3. عكس الناند. Okay? For the inverter, you need 1. To implement the OR, you need 2 gates. Yes.
طيب يا دكتور احنا ايش نسوي هنا؟
هذه بيقول لك انت متورط في مصنع ما عندك الا نور. كيف تسوي اند؟ كيف تسوي اور؟ كيف تسوي نوت؟ انت متورط ما عندك الا نور. فانت متورط ما عندك الا نور. To have a nut, you only need 1 nor. To implement the OR operation, how many nors you need? 2. اللي في الناند كنا نبغى منها 3. To implement the AND, how many nors you need? 2. عكس. تمام؟ يعني النور تقدر تسوي منها OR using 2 gates وتقدر تسوي منها AND using 3 gates. Try to solve this example by yourself. This concludes the material. Anything after that we cover in the slides is not required. I know all of you will not open it, but these are useful information. You may need it in the future, okay? Plus it's hard.
How combination?
Yeah, this is more يعني how to decoder or encoder or شفر. What is this? B? Binary coded decimal. How it works, etc. It's useful. One thing I want to clarify is homework 6. Did you submit homework 5?
Yes.
So I uploaded the solution of homework 5. There is also homework. If you go to homework solution, there is additional problems, okay? This is homework 6 is not required, but are problems for you to practice on chapter 7. Look at the type of problems we might see in the exam. The first problem is to convert binary to decimal. وفيها الدات يعني ما تستخدم الآلة. How to do it? Easy. You multiply by 2 to the power of digits. 101.011, 10111.11. How to do it? You multiply by 2 to the power. This is problem 1. Problem 2, convert to BCD form. So you have the number 11, which is 11. You have to convert it to BCD. How to do it?
Convert it to binary first.
You don't need to. No, he said convert it to binary and BCD. So the number 11, it's in decimal, right? 11 هذا مو 11 هذا 11. Convert it to binary, it is 1011 بالآلة الحاسبة عشان ما في decimal. How to convert it to BCD? Every digit gets its 4-bit. So the first digit 1 will be 001, the second digit will be what? 001. The number 100.75, you can convert it using this method to binary, or you can convert it to BCD. To convert it to BCD, you have 4 zeros here, 4 zeros here, and then 001. قبل الفاصلة. بعد الفاصلة, you convert the 7 to its number 011, or 5, 0101, and you write BCD subscript. Okay? Add binary numbers 100.011. This is how to add them. He shows you the method. It's a very easy question, okay? Hexadecimals, convert them to binary, convert them to octal, convert them to decimal, which is A2.F2 hex. Depending on the question, you can convert it to decimal, and then to binary, it's very easy. To octal, you have to convert it. You have to get the binary code and convert it back to octal. Let me repeat. هذا الهكس. أول شيء كيف تحول الديسيمال؟ You use زي الكويز. 16 to the power 0, 16 to the power minus 1. كيف تحولها لباينري؟ كل ديجيت ال 2 تحولها لل 4 بت باينري، الاف اللي هي 1111 وهكذا. كيف تحولها لاوكتل؟ You get the binary, put it back to octal. هذه التريك to save time in the exam. Okay? This is very challenging. Khaldi, is it clear? So the binary is the bridge between hexa and octal. Problem 5. Perform the subtraction. This is like the quiz. No need to repeat it. Problem 6, the truth table. So in this example, you have to create A, B, and C. Clearly, you should create intermediate variables. The intermediate are A, B prime, A, C, all prime. If you OR them, you should get this result. This result. This operation ABC plus BC truth table. Is it practical in the MCQ? Again, Jason, what's our favorite game? يحط لك هنا ألفا، يحط لك هنا جاما، ويقول لك ألفا plus gamma equal. So you should know how to create truth table. It's probably the easy, guaranteed. Take your time. Take your time, do it. Don't try to shortcut. Create AB prime, create AC prime, all them together. ABC, you should create ABC, you should create BC, and then it should work out. As a matter of fact, you can simplify this expression. What is ABC plus BC? It's A plus BC. A as BC. It is ABC.
Oh, BC.
Take BC and with A plus 1.
Yes, sure. So
A ordered with 1 is A. So it will be ABC.
no, A ordered with 1 is 1. 1, yes.
Oh, A ordered with... Okay, you're right. My bad. So it will be BC. لو تلاحظ
BC bar.
BC bar. BC bar. BC 0 will be 1. 0 will be 1. 0, 1, 0. No, 1 BC is not really.
الجهة الثانية يمكن الدكتور. والجهة الثانية جاب هذا.
I haven't solved it. I'm just solving it. Anyway, can you verify? If it's wrong, let me know, okay?
بس كان
هو صح. السهم هذا على هذا.
صح.
والسهم هذه على هذه. اوكي. السهم هذا نزل تحت. لخبطنا السوليوشن. Problem 7. This is A ORed with B, ORed with C, all ANDed with C. There is a bar and there is another bar. Remember this يا مشعل؟ NAND tied together ايش هي؟ inverter. وهنا في bubble. نفي النفي إثبات. That's why the two bars went away. Jihad. It's almost done. You can leave.
بدل ما انت تقول كويس لو اخذت الزائد صديت الجهه الثانيه يصير عندي او ان وخلاص.
لا تودي الدائره قبل. We didn't teach this in this class.
اعطاني الصوره بسرعه يجيب الكويس.
You can do it, but again, systematic, professional. What if I tell you to write a code to do this? The last problem, this problem, the truth table. It's easy how to create the truth table. This problem is draw a circuit to realize and or or inverter. This is how to draw the circuit. It will be A prime ANDed with B prime or with C, and then here another A prime ANDed with B. Everything is OR. Some students will pull a cable from here to here. That's more efficient, okay? The last problem is De Morgan. Apply De Morgan. It will be A ORed with B or prime, and with C, ANDed with A prime, or with D, and the big bang. We solved this homework in how many minutes?
5 minutes.
So please solve these problems, okay? You have to, so this is required, okay? If you find any mistakes, email Dr. Atiyah.
Only question, bro. What? كم سؤال يمكن يجي من الوقت؟
Everything. Everything is important. This is the revision for chapter 7. I think if you study this, you will get 5 or 6 problems out of 8 problems in the exam. So study it. So the lecture is over. You have any questions? Remember, Sunday there might be a surprise. Okay?